Learn it fast, learn it smart, learn with us at SOFO. Subscribe now for more videos. Contact us for on-demand and regular tuition classes.
Hello and welcome to concept videos from SOFO Learning. We want to go over two simple concepts today. The first one being, if P is a prime number, then there is a unique property that we want to evaluate, that P divides A squared, then P divides A. Now, this concept has a very simple logical explanation. Let's just say that A can be broken down into its prime components. So let's say P1 times P2 times P3. So this is equal to, let's say, 15 being broken down to its prime numbers 3 times 5 times 1. All right. Now this means that A squared is P1 times P2 times P3 times the same set, P1 times P2 times P3. Now let's divide both sides by P, our prime number. So let's say this is by P. Now if this is a perfect division and there is no decimal, no remainder, then this portion has to be the same, no decimal, no remainder. How is that possible? These are all prime numbers. P1, P2 and P3 are prime numbers. P is also a prime number. Therefore, P has to be either P1 or P2 or P3. That's the only way that this can happen. So if P is either P1 or P2 or P3, it is a factor of A, and therefore we logically prove if P divides A, then P divides A squared, and if P divides A squared, then P divides A. The second concept that we want to understand is the fact that square root of 2 is irrational. To prove this, let's just think the contrary, that if square root of 2 is rational, then we have square root of 2 is equal to A by B. Now A by B, A and B are co-prime, which means that there are no common factors between A and B. All right. Now this means that A equal to B times square root of 2, which means that A squared is equal to B squared times 2. I'm sure you know how we got this. If we multiply both sides by B, we are going to get this equation. And if we square both sides, we are going to get A squared is equal to B squared times 2. Now, if we remember that A and B are co-prime, then there are no common factors between A and B. So since there is a 2 right here, we know that A squared has a factor of 2. All right. If A squared has a factor of 2, then A has a factor of 2 as well. That is what we proved just a second ago. So imagine that we can therefore write this as, let's say, A is equal to 2C whole squared equal to 2B squared. All right. So this means that we would have 4C squared is equal to 2B squared. Now if we divide both sides by 2, we are going to get 2C squared is equal to B squared. Now this, by the same principle, this means that B squared has a factor of 2, so B has a factor of 2 as well. So here we proved A has a factor of 2. Here we prove that B has a factor of 2. Now this contradicts our original theory that they are in fact co-prime. They are not co-prime based on this thinking. There is an additional factor of 2 in there. And therefore, since this is false, the mathematics has proven wrong, therefore root 2 is really not rational. Root 2 is in fact irrational. Now, there is something interesting about decimals that are recurring and not recurring. All right. Now, let's just take a number 1.234. Now, we can move this decimal point to the right or the left just simply by adding a denominator or by multiplying using 10 to the power of x. All right. Let's just show this in this manner. 0.1234 times 10 or 12.34 divided by 10 to the power of 1 or 123.4 divided by 10 to the power of 2 or 1234 divided by 10 to the power of 3. We can keep going. But what is important is to understand is the fundamental principle behind it being this 10 to the power of x in the denominator or multiplication can move this decimal point to the right or to the left. What we need to understand from this concept is that if this decimal point was not recurring, we can find a 10 to the power of x associated with the denominator or the numerator that can make it a whole number. Now we can take this fraction and we can keep removing the common factors and make it a co-prime number. So it would come as p by q. See, both have 2 in there, so we can take that off. We can keep going. We can get to a p by q where p and q are co-prime. All right. So what is the key principle that we learned from here? If we can represent a number p by q with the form p by q, which are co-prime, where q can be in this form, 2 to the power of n, 5 to the power of m, then the decimal point is not going to be recurring. Decimal point will end at some point. But if that is not true, if we can't do that, then this 10 to the power of x is simply not possible in the denominator, and this decimal point will keep happening, keep recurring. Those are the 3 simple concepts that we want to review today in this video. Thank you so much.